Hello everyone, this is Mix K. Today I'm going to be showing you guys how to use the balancing chemical equations simulator. So if you look, there are two different parts to the simulator. There's the introduction and the game. So we're going to start with just playing around with the introduction. For your assignments this week though, you're going to click the game part. I'm just going to show you real quick. And there's 3 levels. Okay, you're going to do one level each day, or you can do them all at once. It's up to you. But we have level 1, level 2, and level 3 of the game. And so you're going to go in and play those, or you can do the workout on your own. It's up to you, but this is going to help you with that work. Now for the introduction, I just want to go through just how this works. So up top, you have some tools. So none means you don't use any of the tools. This one shows a little balance that will show how many of each atom you have. So it'll tell you if your stuff is unbalanced. So right now I have nitrogen and hydrogen on one side, but I don't have anything on my product side, so it's unbalanced. You can also see this with a little bar graph. So you can see like how much you have. I like the little balance better myself, but it's the same thing. It's just telling you that they're not equal yet. So you can play around with this. You have control of how many you can put in here. And remember, you're trying to make it equal on both sides. So we want to have the smallest whole numbers that we can that make both sides balanced. Okay, so for the first one, you're going to try and make ammonia. The second one, you're going to try and separate water. And the third one, you're going to try and combust methane. So I'm going to show you how to do it with this first one. And then the second two, I want you guys to be doing on your own. If you get stuck, I'm going to go over them at the end of this video. But I do want you to just pause the video, try them out, and then come back to the video if you're feeling very stuck. So if you need answers to this, you can come back to the video. But I want you to try them on your own. So give them a shot and then come back and look at the answers that I'm about to go over right now. Okay, so if we look here, we can start playing around. Now, if this is a chemical equation, that means we need to have at least something for each of these. So a good place to start is putting one of each, because we have to have at least one of each if they're reacting. Now we notice everything's kind of unbalanced right now. So we want to pick one thing to start. So let's start with nitrogen. So right now I have 2 nitrogens on this side, but only 1 on this side. So I'm going to add 1 more of these because it'll add 1 more nitrogen. But the problem is when I did that, now I have more hydrogens. So I have to come back over here. We can see that our nitrogens have already become balanced. But I'm going to come back over here, and now I'm going to increase my hydrogens until both sides have the same amount. So if I put another hydrogen molecule, it's not quite balanced yet. I can add a third one, and now it's telling me I am balanced. Okay, so now let's try the next one. Remember, I do want you to try these on your own first. Now, let's say I added too many real quick before we try the next one. If I put an extra one here, we're going to see that we're unbalanced again. So I can also decrease the amount on this side. So we got to be careful. Now, I want you to be thinking about how you're doing it. So I did one element at a time. Don't just throw random numbers in there or you're going to get stuck for a really long time. So now the only thing here is with this one, we put this 1 here as a counter, but when we write this chemical equation, we won't write the 1 in front of this because chemists never write the 1s. They say, you know what, it says N2 there, you know there's at least 1 of it, you don't need to write the 1 here, but we have it as this part of this counter as part of the simulator. So now let's try to separate water. So I'm going to start again by doing 1 of each because that's a good place to start. Now, if I look, I have 2 oxygens on my product side, but only 1 over here. So I'm going to need to add another water to make sure that I have 2 oxygen molecules. So I'm going to put another water over here. Now, when I made oxygen balanced, it made water unbalanced, and that's okay. We can go back and now change hydrogen instead. So if I look over here, my hydrogens are unbalanced. So I'm going to add another hydrogen on this side, and now we're all set. So we cannot do half of a molecule. If we go back to 1 of each, it would seem easier just to say I have half of an oxygen and then there'd only be 1 of them. But oxygen always comes as a pair. So we have to make sure that we're doing it as a whole number ratio. We can't do half numbers. And that's why these counters are on full numbers. So if I, oh wait, that's wrong. Boop, back. Okay, so if I go back to my balanced equation, I have whole molecules. I can't have half a molecule. Okay, last example. So combust methane. So this one's a little more complicated. We have 3 elements going on, and we have elements in multiple areas. So what we want to do is, a good way with combustion reactions is we want to leave oxygen for last because it has the most freedom here. So let's start with our carbon. So I'm going to put one of each to start because there's always going to be at least one of each of them. Now, if I look at my carbons are balanced, so that's good. But my hydrogens are not. So I have 4 on my reactant side and only 2 on my product side. So I'm going to increase my water so I can increase my hydrogens. So if I increase that, now my hydrogens are balanced, but my oxygens are not. So my reactant side has too few. Now, this is why it was nice to leave oxygen for last. This one is just oxygen. So if we change this, none of the other elements are going to get messed up because we just worked very hard to change the carbons and hydrogens to equal each other. So we don't want to have to change anything else except for these oxygens. So if I increase my oxygens, I'm balanced. Okay, I hope this helped get you guys a better idea of what we're doing with this simulator. Make sure that you're trying to balance each of them, and you want to do it in the smallest whole numbers possible. So like if I doubled each of these, for example. Oh, it doesn't let me go that high. Let me look at a different one. Let me go back here. So let's say, oh, it doesn't let you in this simulator, but let's say you did double the amount you needed. You would want to make sure that you have the lowest ratio possible. So I wouldn't want to have like 4 to 4 to 2. I want it to be 2 to 2 to 1. That's the simplest ratio possible. Now, remember, for the game, you can use the game part to help you out. You'll have similar setups where you'll have 2 different sections for your reactants and products, and you can go through and fill them in and try to figure out if it is balanced or not. You do not have to use the game portion of this. It's an added tool. So if you like the method I went over in the notes video, you can use that. But if you need a little extra help, you can use this game to help you get going on it. Okay, thank you guys so much. I'm going to end the video here. Please let me know if you have any questions or concerns.